All right, example 5, find an equation of the tangent line. So there's the same problem that keeps on happening again and again and again in this problem, on this book, right? Find the equation of the tangent line. Okay, so we want it to be tangent to the curve y equals x plus sine of x at the point pi over 6 comma pi plus 3 over 6. All right, so x comma y, all right, there's those values. If I put pi over 6 in place of x, pi over 6, sine of pi over 6 is 1/2, which is 3 over 6, so pi plus 3 over 6, that's where they got that from. Again, they're just giving you the coordinates of the point. How do we find the slope of the tangent line? How do we find the slope formula for the tangent line for this specific curve? Anybody remember? Find y prime. Find the derivative. Slope of a curve is always simply the first derivative of that curve. The derivative of x is 1. The derivative of sine of x is cosine of x. So the slope of this curve, the slope formula for this curve, is simply the first derivative, which is 1 plus cosine of x. And keep in mind, this is just a sum of functions. This is a polynomial structure, so I'd use the power rule, or actually just the derivative of x is 1 rule. This is a trig function, derivative of sine of x is cosine of x, so each individual piece, since they're being added or subtracted, we're allowed to take each individual derivative. If it was x times sine of x, now I have to use the product rule, 1d2 plus 2d1. Again, really focus on structure in each problem to establish what type of differentiation is necessary to differentiate this thing. So, this one's easy differentiation. Derivative of x is 1, derivative of sine of x is cosine of x. The slope, then, is going to simply be 1 plus cosine of what? Very good, pi over 6. That's x in our point of tangency, so the cosine of that number, and hopefully we recall the cosine of pi over 6 is the square root of 3 over 2. Oh, yeah. It's one of those sine cosine memorization quiz issues that we had last year. We memorized all the sine cosine values from 0 through 2 pi in the radian world and 0 through 360 in the number world. Pi over 6 was square root of 3 over 2. Square root of 3 over 2 plus 2 is just the square root of 3 plus 2 all over 2. Okay, that's the exact slope. Okay, I would like you to kind of go through getting the exact numbers like that. For the sake of actually getting the actual answer to the equation of the tangent line, I'm fine with approximates, but give me the exact answer first before you go approximate on this thing. Give me a couple decimal, let's go 4 decimal places on everything. So if I type in my calculator, I want to type in the square root of 3 plus 2 over 2. Notice I put a parentheses, square root of 3. Remember this calculator, the square root bar keeps going until you tell it to get out of there, so press to the right to get out of the radical. Plus 2, in parentheses. So that's the entire square root of 3 plus 2 on the top, divided by 2 equals, and that comes out to 1.8660. The other thing that we have approximates for will be that point of tangency. So again, if we get that approximate, if I'm going to approximate anything, I might as well approximate everything. So if I type in pi divided by 6, that equals 0.5236. If I type in parentheses, pi plus 3, in parentheses divided by 6, that equals 1.0236. Alright, so I have a slope, I have a point of tangency, so at this point now it's just an algebra 1 problem. It does involve decimals and 4-digit decimals, whatever, but again it's just y equals mx plus b, y equals mx plus b. So 1.0236 equals 1.8660 times 0.5236 plus b. B is simply going to be that number minus the product of those two numbers, right? I can actually type in my calculator just like that. So 1.0236 minus 1.8660 times 0.5236 equals 0.0466. 0.0466. 4 decimal places on that also. So I have a slope of 1.8660. I have a y-intercept of 0.0466. So y equals 1.8660x plus 0.0466 would represent the equation of the tangent line. As always, that is a checkable thing. If I type in my function x plus sine of x as function 1, and my derivative by tangent line formula 1.8660x plus 0.0466. I want to make sure this point of tangency is in on my graph, so maybe y goes from -1 to 2, and or x goes -1 to 2. Maybe y goes from -2 to 4, something like that. Oh, magic numbers here. So -1 to 2, and let's go to -2 to 4. See what happens. As long as that point's within that window. So there's x plus sine of x. It's kind of straight line-ish there, isn't it? It's kind of starting to bend there. There's my tangent line. And it kind of rides along the curve pretty much there, so maybe if I extend the window out a little bit more, let's go from -3 to 6, and let's go -5 to 8, I don't know, let's see what happens. There's a little bit more curvy. Starts bending down, starts going back up, and then my tangent line, right there.
That's a nice graph.
It looks tangent, so I would call that good. All right. Notice that to the graph itself, it's actually secant because it goes through here and also cuts again there. That's just because that's the way the graph's shaped. There's no way to avoid going back through it because it's here and it bends up and over, so it's going to have to go through twice. But there's no way to avoid it. But anyway, that's the way to check to see if your tangent's good. If it looks tangent, it's right. If it doesn't look tangent, let's say you did something weird and got a -1.8660. So there's your graph, and then your line of tangency looks like this, let's say. You're wrong. Okay, so it's pretty obvious when you're wrong. Another thing that might have gone wrong is maybe you got the wrong y-intercept. Let's say you thought it was 1.046 instead of 0.0466. So there's your initial graph. I wish we'd just keep that graph there. All right, there's our initial graph, and we think this is our line of tangency. Yeah, that doesn't look tangent either. So, if it doesn't look tangent, you did something wrong. If it's going the wrong direction, you messed up with the slope. If it looks like the slope's right, but you're kind of not in the right position, you probably messed up with the y-intercept. Okay, but
close but no cigar.
yeah, it should be a lot closer than that. Should be able to see daylight between them. So, again, use the calculator to verify answers. If you get them wrong, try and find your mistakes in your work.